Machinability. This lecture will be dealing in a few parts, and this is the part 1, the first part. This topic, machinability, is in unit 2 of the subject machining sciences, which is taught at the 4th semester of the production and industrial engineering branch at RTU Kota. So let's study this topic, machinability. The topics which will be covered in this presentations are concept of machinability, machining index, and factors affecting machinability. So let's study machinability. Machinability, its definition is very simple. Machinability is the ease with which a given material may be worked with a cutting tool. The better the ease, the better the machinability. With more ease, if we are able to cut, then the machinability is good. Now, what are the factors that determine machinability of a material? Please keep in mind that machinability is property of a material. So, the 4 main factors which constitute or which determine machinability of a material are its surface finish, its tool life, force and power required, the level of difficulty in chip control. Thus, we can say good machinability indicates good surface finish and better surface integrity, a long tool life, and also low force and power requirement and desired chip control in the cutting zone. If all these things are there, we'll say that this material exhibits good machinability. Now, how to measure machinability? So, to measure machinability, we have what it is called Machinability Index. In many textbooks, it is referred as Machinability Rating. Now, Machinability Index or Machinability Rating, as it is called, it is an index or it is an indicator to quantify machinability of various metals so that we may compare which material is having better machinability. Now, how to calculate this machinability rating or machinability index? Here is a simple formula for that, and the formula is Km is equal to V60 upon VR. Now we are having two new terms. One is V60 and one is V60R. Let us see what are these two new terms. V60 is the cutting speed for the target material that ensures tool life of 60 minutes. That means at what speed I can cut the target material to get a tool life of 60 minutes. Similarly, V60R is the same cutting speed for which we get the tool life of 60 minutes, but for the reference material. Reference material, please say this is the target material and this is the reference material. So V60 is for target material, V60R is for reference material. Now, here we see if Km is greater than 1, the machinability of the target material is better than that of reference material and vice versa. Note that this system can be misleading because the index is different for different machining process. What it means to say is, for one process, you will get different machinability index, but for another process using the same material, you will get another machinability index. So it can be misleading. While we are quoting machinability index, we'll also have to refer the reference material as well as the machining process. As I already told you, the machinability index is also known as machinability rating or machinability index with help of an example. In this example, we are taking three materials, that is AISI 1112 steel, Austenitic 302 stainless steel, and also AISI 1045 steel. In this, we have taken AISI 1222 steel as a reference material. This is our reference material. So naturally, for reference material, the index will be 1. But to compare this reference material with other material, we need to calculate or to find out its V60R. So V60R for this AISI 1112 steel, we have found out to be 0.5 meter per second. This means that if we'll have the speed of 0.5 meter per second, this material will give us a tool life of 60 minutes. Or vice versa. Conversely, if we want to have a tool life of 60 minutes, we'll have to keep a speed of 0.5 meter per second. Therefore, V60R is 0.5 meter per second. Now, once we have set this as reference material and also calculated V60R, we come to our first target material, that is Austenitic 302 SS steel. For this, first we'll calculate its V60, and that is tool life for 60 minutes, and that we have found out to be 0.23 meter per second. So using this 0.23 meter per second, we calculate the Km as 0.23 of this target material, V of this reference material. Therefore, Km we have calculated as 0.46. Similarly, for AISI 1045 steel, we have found out its V60 is 0.36 meter per second, which will give us a tool life of 60 minutes. Now, using this value of 0.36, we have calculated Km is equal to 0.36 divided by 0.5, and that is 0.72. So, if you want to conclude this analysis, this simple piece of analysis, we can say that the following three steels can be ordered in descending order of their machinability as AISI, that is AISI 1112, that is having highest machinability because its index is 1. Second, AISI 1045 because its index is 0.72. and also authentic 302 stainless steel, whose index is coming out to be 0.46. So in very simple and layman term, we can say that this steel is easy to machine as compared to this steel. Machinability. What are the factors that affect machinability? So there are four main factors. We'll just enumerate these factors here, and we will discuss in detail each of these factors in our next part of this presentation. So here we are just enumerating the four factors, and they are: the first factor is work material. So what is the type of work material, what its properties, and all those things will determine the machinability. Second is the cutting tool, what cutting tool we are using, what is its geometry, what is its material. All those things will also determine the machinability. Third, naturally, is the process parameter. That means what is the cutting speed, what is the cutting feed, what is the depth of cut, and all such parameters, they also determine the machinability of a material. And the fourth factor which affects the machinability is the machining environment. So we'll discuss all these four factors in detail in our next chapter, next presentation. And this brings to the end of part 1 of our presentation on machinability. Thank you.